industrial site. It could be a manufacturing site or a fulfillment center. Typically, such sites have thousands of equipment that drive complex operations. For an operator to be able to meet their daily production targets, they need all this equipment working 24/7. However, they are faced with a lot of failures on these assets, and that leads to stopping of production lines and leads to unplanned downtime. Today, we will be talking about how Amazon Monitron can help enable predictive maintenance. I'm Shalika Pargal, the product manager for Monitron, and I'll be joined shortly on stage by Dave Croning, monitoring and diagnostic leader at KAES, and Hunter Lowmaster, operations diagnostic leader at KAES, to talk about KAES's journey with Monitron. We have a packed agenda today. We will start out by talking about predictive maintenance at scale, talk about why it is critical and how Amazon Monitron enables predictive maintenance. We will then have Dave and Hunter walk us through how KAES has scaled their predictive maintenance program over the years with Monitron. There are a variety of different maintenance strategies that customers deploy. Let's look through those. The first strategy of phase one is the reactive strategy. In this strategy, you basically wait for something to fail before you fix it. This is not a recommended strategy. However, we do have customers who use this. And it could be in scenarios where, say, the asset is not as critical, so it's okay to let it fail, or the asset is hard to reach. In that case as well, you might want it to let it fail. Again, this is not a recommended strategy, but customers do use it. Phase two, or planned maintenance strategy, is a strategy where, on a scheduled basis, a technician is sent to the asset to take measurements of the assets. These measurements could be non-invasive measurements, say, for example, the temperature of the asset. An increase in temperature is an indication that there is more friction on the asset, or it could be more invasive measurements. For example, the technician would be required to connect probes to the asset to capture, say, the current or some other dial on the asset. This strategy has its own challenges. Firstly, it is planned, so you do it on a weekly basis, monthly, or quarterly basis. It is not in real time. It's similar to your car servicing. So where you have a planned maintenance, you do your oil change, say, every 5,000 miles. So it's not on a need basis, but on a fixed schedule. Secondly, there is human intervention involved. A technician needs to be sent to take measurements of the asset. When a person has to take more invasive measurements, there is always a risk of getting injured. And say the technician is at a risk of being injured, then the production line needs to be stopped, which is, again, a disruption to the service, and this could result in having unplanned downtime, which is an expensive event. This strategy, though, is not recommended and has its own downsides. We do have customers who do use planned maintenance strategies. Third phase, or the predictive maintenance phase, if phase one is wait till something breaks, phase two is do it every month or every quarter or every week. Phase three is wait till just about to break. So getting real-time visibility into the health of the asset just before a failure happens. This is the most desired strategy. However, this also has its own challenges. The challenges are in terms of how do you implement such a strategy. This also requires the technician to be involved, but not to take measurements. Here, the technician is involved to be able to set up and install sensors. These sensors capture measurements from the asset, which are then sent to some place for processing. Again, the data needs to be captured, then sent up for processing, so that we can gain some insights from this data. To be able to gain insights from this data, you require, say, advanced analytics or machine learning, or you need some kind of analysis of the data done to be able to gain some meaning out of this data. So this is the desired strategy. However, it is very hard to implement. Like many things Amazonian, we work backward from the customer's requirements. Customers wanted a predictive maintenance solution. They wanted a fully managed solution, easy to implement, and cost-effective. And that's what we did with Amazon Monitron. Before I move on, any users of Amazon Monitron? Can I see a show of hands? I see a few. Have you all heard of, can I see a show of hands of who has heard of Monitron before? Okay, that's good. Amazon Monitron is a fully managed end-to-end system that monitors the health of your asset and detects abnormal conditions using ISO and machine learning models. In doing so, it enables predictive maintenance in an easy and cost-effective way, thus helping stop or reduce unplanned downtime. It is done on a real-time basis, not a periodic basis, so there's constant monitoring of the health of the asset. It includes managed hardware, so it includes sensors and gateways that capture the measurements from the asset and send it up to the cloud. Now let's look at how it works. On the left-hand side, I have my operations site, which has some machinery. So Monitron includes everything you need to get started to monitor the health of your assets. It has purpose-built wireless sensors that capture the temperature and vibration parameters of the asset. These sensors are self-powered and do not need to be plugged in. So to get started, you connect the sensors up to the machinery, and using your mobile Monitron app, you use near-field communication to commission the sensors. Next, it includes a fully managed gateway. This gateway securely and automatically transfers data to the cloud via your local area network. In the cloud, we have the Monitron service that analyzes the sensor data using ISO models as well as machine learning models that it has built. To view the health of your asset and to get real-time notifications, we have Monitron apps. We have the mobile app as well as the desktop applications. These applications are used to set up your sensor and gateway as well as to get real-time notifications in case of an abnormal condition on the asset. Now, imagine we are in the process of actually monitoring this machinery that we have on our site, and something goes wrong on the machine. It could be that maybe the temperature is increasing or there's increased vibration on the machinery, and we know that something could potentially go wrong with this machinery. This data is collected by the sensor and sent up to the gateway and up to the cloud. In the cloud, the machine learning and the ISO models detect a change in the pattern of the data, analyze it, and generate real-time notifications, which are sent to the technician to take immediate action on these assets. The real-time monitoring of the assets, as well as looking at the health of the assets, can be done via the Monitron apps. We have a web-based app as well as mobile apps. You can see historical data as well as real-time data. On the left-hand side, you see a list of assets I have in this operation site, and you can see the statuses of the various assets. Some of them are in alert, some are healthy, some are in maintenance. This gives a view of your complete site. Just to summarize, Amazon Monitron is not a planned or a reactive service. It is a real-time, continuous real-time and automated service which continuously collects temperature and vibration measurements from the assets. This data is then transferred to the cloud where it is analyzed using ISO standards, ISO 20816 vibration standards, as well as the sensor data is analyzed by the machine learning models that have been built. The machine learning models are in a learning phase for the first 14 to 21 days after installation. They listen for incoming sensor data, analyze the data, learn from the data, and then predict failures in the future. Once an anomaly is detected in this data pattern, an alert is raised, so a technician can be sent out to look at the asset. The technician, when they look at the asset and fix an issue, or they evaluate the alert, they provide feedback back to the Monitron system. This feedback that they provide to the Monitron system is used to further educate the ML model. And this becomes like a continuous cycle of collecting data, analyzing, learning from it, and then doing better predictions in the future. As our customers scale, they want to use Monitron for all their predictive maintenance needs across all their manufacturing sites globally. Amazon Monitron is your one-stop solution for all your predictive maintenance needs. With Monitron, you can start monitoring all your rotating equipment like pumps, motors, fans, etc., in a matter of minutes. These assets are critical cogs in many manufacturing sites across a different set of industries. Over the last year, we as a team have worked on building functionality that helps customers scale. Customers in oil and gas, chemical, and other industries have been asking us for sensors that are certified for hazardous areas. The hazardous areas require sensors to have special certification so they are safe to be used in such an environment. So I'm happy to announce that Monitron sensors now have Class 1 Zone 2 certification for US and Canada, and ATEX and UK EX certification for EU and UK. These sensors are available for purchase via Amazon.com and Amazon Business in US and Canada, and will be available for purchase in EU and UK shortly. For a customer to get started with Monitron at a new manufacturing site, they need the Monitron sensor to be certified for that country, and they need access to the service. When we launched, this was about 3 years ago, Monitron was certified for US, Monitron sensors were certified for US, Canada, EU, UK, and Turkey. And the Monitron service was available in 2 regions, IAD and Dublin. However, as our customers as they scale, they want to install Monitron at their sites in Asia Pacific and Latin America. This has led us to certify our Monitron sensors for these regions. In Asia Pacific, Monitron sensors are certified for Japan, Korea, Australia, New Zealand, and Singapore. And in Latin America, the sensors are certified for Brazil, Mexico, Chile, Peru, and Colombia. As customers scale, we wanted to make sure they don't face any latency with the service. So we launched Monitron in the Sydney region as well, in addition to IAD and Dublin. One of the hurdles that customers face when they want to get started with Monitron was a requirement to have their IAM identity center in the same region as the Monitron service. To ensure that customers can quickly get started with Monitron, we have now added cross-region support. Monitron service now supports IAM identity centers in all regions except opt-in and government regions. What does this mean? So as a customer, you can use any Monitron in any of the 3 regions, that is IAD, Sydney, and Dublin, with your IAM identity center in any other region, making it easier to get started with Monitron. As customers standardize on Monitron for all their predictive maintenance needs, as a team, it's critical for us to make sure that the Monitron data is available to customers in their ecosystems. Customers can export the Monitron data using the Kinesis data stream. The Kinesis data export enables customers to be able to create work orders in their enterprise asset management systems like IBM Maximo, SAP PM, so a technician can be sent to fix an asset with abnormal conditions. It can also be used to build operational dashboards to monitor the health of their assets. And in our Amazon Fulfillment Center, we have integrated the Monitron data into Amazon Chime, which is a conference calling and chat service, where based on an alert, a notification is sent to a group of technicians who are responsible for a particular site using the chat room. Over the last year, we have enhanced the Kinesis data export. We have added more insights about the Monitron sensors and gateways, including connectivity status, included asset state transition events triggered by the user. These are like closure codes, closure reasons. What these enhancements do is make it easier for customers to build a tighter integration into their work order system. Now, changing gears, Koch Agriculture and Energy Solutions were early adopters of Monitron. Over the years, they have scaled their predictive maintenance program with Monitron. I'd like to welcome on stage Dave and Hunter to walk us through KAES' journey over the years. All right, thank you.
All right, good morning, everybody. So first, I'll step through and give you an overview of our company, my role, and then try to share what we've done from a scale perspective. So Koch Ag and Energy Solutions is a wholly owned subsidiary of Koch Industries. We have four main businesses that we focus in on. One is fertilizer, where we manufacture and distribute over 13 million tons of nitrogen-based products annually. Koch Energy Services, main focus is really around the distribution and sales of natural gas. Koch Methanol, similar to fertilizer, where we manufacture and distribute methanol products. And then Koch Agronomic Services focuses in on micro-based nutrients that help increase yield as well as decrease the impact of the environment. So then in my role, as the monitoring and diagnostic leader, I help our team take the data from our assets, so a piece of equipment, apply technology, knowledge, and context, and then leverage that to then provide insights back to our manufacturing facilities. So to give you an example, it'd be a process deviation where a temperature goes up or pressure goes up, or a machinery is not performing at its ideal condition. We'll send those notifications to the operations team. So on our deployment, I presented in 2021 on where we have gone with our initial deployment. And we started off with think big, start small, scale fast. And so we did the first two really well. We said we want to put this on everything. We want to do a quick experiment, put 10 sensors out, prove the value. But then when we went to scale, we struggled. And so Hunter will step through that in more detail. But we've refined the opportunity a little bit more and said, okay, how do we work with our SMEs a little bit closer on what machinery they want to monitor? And then how do we work with some other partners in the organization to scale that technology? And then my team helps with the insights on leveraging that data to provide context back to the sites. So since we're at an IT conference, we'll go through a little bit of architecture. We take the asset data from the Monitron sensor, as Shalika had mentioned. It goes to our gateway. In our environment, we leverage the PoE gateway, the top one there, the power over Ethernet. Then it goes to our wireless access point where it hits the cloud. And then what we do from there is we take the data and leverage it through the Monitron app. And then that feeds either our SMEs, the monitoring analysts, the operators to get it on their phone. The other path that we took too is we leverage that Kinesis stream. We feed our data historian, provide additional context, leverage our models to then feed our analysts to provide more insight to what's going on. So the approach to deployment that really helped with scale was our focus on comparative advantage, which enables employees to maximize their overall contribution to the organization. And the way we did that was first looked at what was dragging us down. Where were we struggling to get this done? And it was really around the organizational transformation focus in manufacturing. It's a tough hurdle to get through. We went to the I&E group, which is the instrumentation and electrical team, said, hey, would you help deploy this solution? They were overloaded. They have all the priorities to keep the plant running, the current technology, the wired instruments going. So the wireless sensors for vibration were really lowest on their priority. So I came from the IT organization, knowing that the IT OT team was aligned to the value and understand the millions of dollars that we could potentially save with this solution, enabling these insights, as well as they knew where the wireless points were to go install some of this technology out in the field. So the easy part was putting the sensors on with the direction of our SMEs. The harder part was really putting the gateway infrastructure in to make sure that we're feeding that data in accordingly. So long term, we do see the sustainment ownership transitions into the site itself with the capabilities we have. But over the short term, to help us accelerate, it's really been the IT OT team to leverage that deployment strategy. So I'll let Hunter talk through a couple things on leveraging the insights. So how did we really capture value from this? And then where did we go? What was our journey like along the path?
Hello, I'm Hunter Lowmaster. I'm the Operations Diagnostics Leader with KAES. And today, like Dave said, we are going to talk through how we're leveraging this data. First, we utilize the desktop and the mobile application, send that straight to plant operations, the people, the boots on the ground, your operations people or maintenance teams. And then second, we leverage the Kinesis stream, and that goes to our AI ML models that we have, and that goes through Dave's team, the M&D team, our analysts. Still, we get that to the right people, plant operations, the people who can take action. That's the main key here, is getting this data to the people that can take action at your facility. The quickest, that's how you're gonna get value. So I'm gonna talk through 3 different wins that we've captured with 3 different outcomes. This first one, as you can see up there in the top left in that graph, we had a step change of vibration magnitude that was identified with the Monitron application. This is on a gearbox, between a gearbox and the coupling. So see the step up, we had our analysts take a look at it, send it to the site. Decision was made to swap pumps for inspection. Upon further investigation, you can see there we had a failed disc pack right there where it had split. This is a failure that we caught that, imagine if this failure keeps going, nobody's walking by this, we don't have the sensor on there, it's gonna end up being a bad day because that coupling sooner or later is gonna completely fail on you. So what would happen, loss of ammonia, cooling tower pump due to the coupling, we'd have to switch to the backup, hopefully we do it in time before the plant comes all the way down. Instead, leverage the data from this sensor, we were able to bring it down and replace this pack, with minimum impact to the business. The second one, on Thursday, July 6th, this plant's located in the Midwest, so you can imagine it's hot, like here in Vegas. We had a step change that was identified on the vibration of a large cooling tower fan. Our analysts shared this with the operations team. Operations go up there. These are located on a high platform, hard to get to. People don't like going up there, especially in the winter. Fan sounded different. So decision was made, we need to go ahead and run this through the weekend. The next day, you can see in the application, the M&D analyst communicated that another step change occurred. So another change in vibration. At that point, with operations decided to slow the fan down to 50%. And that's where you can see the blue, kind of where it goes back in the blue, and that step change of vibration comes back down from taking load off of the gearbox. And then we put together a repair plan. The loss of the fan, if we would have lost this fan, keep operating it, we would have resulted likely in a plant shutdown. Site worked to get a spare motor and gearbox on site, and they were able to do this during the evening when it was cooler temperatures outside. The key here with the data is that it allowed the business to make multiple decisions. The first decision was, this was on a Thursday, our maintenance team doesn't work through the weekend, let's just keep an eye on it, let's see what's happened, we'll address this on Monday. And then the sensor allowed us to make another decision when the second step change occurred that no, we got to slow this down. We need to do something about this now, this weekend, before the plant comes down. So that's where a lot of the value came in this sensor. This is an example of a failure that it was going to fail. There's nothing we could do about it. But the data from the Monitron sensor allowed us to make the best business decision to get the best outcome for our site. And in this last one, we just have a simple blower that you see there in the bottom right. It's a belt-driven motor, or belt-driven blower, excuse me. And it's one of those where we just start seeing erratic vibrations. It picks it up in the application. And it's as simple as send somebody out there, go ahead and shut it down, swap to this other blower, and do a belt alignment and a filter change out. This is an example of one that's not something like this with belt-driven equipment. Your site may have a time-based PM on, say every 6 months. Your maintenance team goes out there and inspects the belts, inspects the filter, changes out the filter. But maybe after 4 months, that belt needs replaced, something happened, misalignment. So this is where the value capture came from this. Instead of waiting for that PM to come up, no, we need somebody to go out there today, shut it down, do some work on it. Then we'll talk about growth and scale. We deployed the first 5 sensors back in 2020. They're still in service. Those 5 sensors were actually on the last slide on that aeration blower. Still out there working just fine, and we've had detected several predictive maintenance activities due to those sensors. In 21 and 22, limited scale, Dave talked to it, infrastructure, the people, it's usually your biggest hurdle in scaling anything. We had 133 sensors across 5 sites, trying to get everybody on board through the organization. And in 2023, our business really had an increased reliability focus, key performance indicators, and new mindset to deploying. We've now deployed over 536 sensors, and since we created this, it's grew probably by 50, 60 sensors, or 458 assets. We've captured hundreds of anomalies, led to process changes or work orders to repair equipment, and we deployed our first round of C1D2 sensors that Shalika announced earlier, expanding possibilities to monitor new assets in a different way. And it's going to open, these C1D2 sensors are really going to allow us to expand through our facilities. We make methanol, we make fertilizer. We have a lot of hazardous areas that previous sensor was hindering us from deploying. We have value realized, the role transformation, elimination of route-based readings, 1 per month to 720, increase the value of time, working on solutions instead of identify problems. So we have somebody going out there all the time taking handheld readings on equipment that's healthy. Well, we can leverage the sensor and the Monitron application to go ahead and give us the confidence that that asset is healthy. We want that person working on assets that are not healthy, not out there taking readings on stuff that is fine. Focus on improving internal customer experience, deliver a higher level of services for our customers. We have our M&D team monitoring and diagnostics. Our customers are our sites, so we want to be able to give them the confidence that their assets are healthy and fine to run. And elimination from equipment failures, prevented over 50 functional failures, estimate savings over $500,000 or 10x per sensor deployed. That's it. Thank you.